Okay, so let us start. Good evening to all. My name is Abhishek Pandey. I am a Prime Minister Research Fellow in the discipline of Mathematics at IIT Bhubaneswar. Today we are going to discuss about Week 8 assignment, Multivariable Calculus. So let us start. So the first thing, so this assignment is related to Green's theorem, divergence theorem of Gauss, and Stokes theorem. So let us first see Green's theorem. Okay, so let C be any piecewise smooth. Okay, let C be any piecewise smooth, piecewise smooth, piecewise smooth closed curve bounding a region. Oh wait, something else. Simple, piecewise smooth, simple closed curve. Piecewise smooth. Simple means it does not intersect itself. Okay, means the function is one. Curve bounding a region R, bounding a region R. Okay, if f comma g del f by del y and del g by del x, del f by del x and del g by del y are continuous on R, then so this integral over C f of x comma y dx plus g of x comma y dy is basically equals to double integral over this region R del g by del x minus del f by del y dx dy. Here it should be del f by del y and del g by del x. Okay, and the integration being carried in the positive direction. Positive direction means anti-clockwise. In the positive, so it means anti-clockwise on C. Okay, so this is the curve. So basically it is like, suppose this is your simple closed curve. Okay, this is your C and this is your domain. This is your A, this is your R, bounded by C, I mean enclosed by C. Okay, so this is your R. So basically integral over C converted to the integral over this region R. Okay, so let us see some problems. So we'll move towards problems where we are going to use this thing. Question. So use Green's theorem. So use Green's theorem to evaluate this following integral dx plus x square y cube dy. Okay, where C is the triangle with vertices 0 comma 0, 1 comma 0 and 1 comma 2. with pos with obviously positive into orientation. Okay, so let us first see what this curves means. So here's the thing. So this is your uh, so this is your 0 comma 0. Sorry. So this is your 0 comma 0. This is your 1 comma 0, and so this is your 1 comma 2. 1 comma 2. Okay, so this is your, this will be your triangle. Okay, so this is your C. Okay. And we have to take the anti-clockwise, so this is the direction. So this one, this, and this. So this is the direction. Okay, this is your R. This is your C. Okay, fine. So now solution. So now here f of xy is x into y, and g of x comma y is x square y cube. Okay, so by Green's theorem, by Green's theorem, Green's theorem, this is, just wait a minute. So by Green's theorem, this is equal to, so by Green's theorem, this is equals to c xy dx plus x square y cube dy. This will be changed to this r, and so this is your g dy. So this will be del g by del x minus del f by del y, or you can write dy dx. Okay. So this is nothing but over r. Okay, so del g by del x is nothing but 2xy cube. Okay, so 2xy cube minus del f by del y is nothing but x. So dy dx. Now we have to put the limits. Okay. So limit, how we will put? So we want y limit to be variable of x. Okay. So so now we have to see what is this curve equation is. Okay. So this, the equation of this one is basically y equals to 2x, isn't it? Is it okay? So what we will do, we will draw a horizontal. Okay. So limit of y, so limit of y is equals to 0 to 2x, and x is from 0 to 1. Okay. Now we just have to integrate this one, and this will be 2 by 3. So the only thing is how we are converting this and how we are getting the limits. That is the only main thing. After that, there's only calculations. Okay. Now let us see the next question. So, एक पे कर दो, एक पे. Okay. So let us see the next problem. Okay, so the next question is, evaluate integral over c y cube dx minus x cube dy. Okay, where c are the two circles circles of radius 2 and 1 centered at the origin with positive orientation. So how to solve this one? Okay, so this integral c y cube dx minus x cube dy, this we can write it as, okay, so 3 will be common, okay, because this will be 3x square minus 3y square, and this integral dA over this region R. Okay, so the curve is, okay, so this is thing, okay, so this is your region, okay, R. Now, what we will do, we will use the polar coordinates, okay, so this will be, I guess, this will be minus 3, is it okay? M dx plus n dy. So n is here minus x cube. Yeah, so this is the thing. Okay. So minus 3 double integral over r x square plus y cube dA. Okay. Now, if we convert this in polar form, we will get, so theta will be from 0 to 2 pi and r will be from 1 to 2. So this is your thing. R is from 1 to 2 in this. So R is from 1 to 2, R square into R. So this is R square into R, dr d theta. So now this is easy. 1 to 2, R cube dr d theta. And this will be nothing but minus 45 pi by 2. Okay. I hope this is clear to everyone. Okay. Let us move towards the next problem on Green's theorem. Fine. So the next question is, the value of the integral this over c y dx plus integral this c y dx plus x square minus y cube dy. Okay, so where c is the boundary of the region enclosed by y equals to 0 comma y equals to x and x square plus y square equals to 4. So let us do this one. First thing what we need to see is, okay, so the curve is y equals to x, okay, and x square plus y square equals to 4, okay, so this will go over 2, radius is 2, okay, so fine. Okay, so this is, and y equals to 0 is x axis, so this is your y equals to x, this is 0 comma 0, this is 2 comma 0. Okay, and once you put so this will be root 2, I guess. What is here? X. So intersection of this one, so this will be x square plus x square equals to 4. So this will be x square equals to 2. This implies x is equals to root over 2. Okay, so y is also root over 2. So this point is under 2 root over 2. Okay, this will go to here also. So what we need to do is we have to take the uh, positive orientation. Okay, so here we can use the by Green's okay, no, so fair f of x comma y is here y, and g of x comma y is basically x square minus y cube. Okay, so by Green's theorem, by Green's theorem, this integral y dx plus x square minus y cube dy, this will be equals to, on this region R, and so Yuvraju, can you mute yourself?
Just a minute, sir. Just a minute, sir.
Yes, yes. So this will be 2x minus, this is 1. So this is your m, this is your n, g. So del g by del x, okay, this will be 2x minus del f by del y. So this will be 1. Okay. So this you will get as 2x minus 1 dx dy. Okay. Now you have to use the polar coordinates. So use x is equals to r cos theta, comma y equals to r sin theta. Yuvraju, you can mute yourself and your video also. Please mute yourself and your video also.
Yes, sir.
Please mute yourself and your video also. Your video is on. Okay, so y equals to r sin theta, where r will run from 0 to 2 and theta will run from 0 to pi by 4. Okay, this is quite clear because this will be pi by 4 only. Okay, wait a minute. Yeah, fine. Okay, so this will integral will be r equals to 0 to 2, theta is from 0 to pi by 4, and this will be 2x minus 1. So x is equals to r cos theta, to 2r cos theta minus 1 r d theta dr, and this will be 1 by 6. This you can calculate because I have already solved this one. So the only thing is you have to properly get the limits. Okay. Now we'll see one more problem and then we will move forward to the next concept. So the next question is the value of integral over c x y minus y square dx plus x square minus xy dy, where C be the boundary of the region R is equals to x comma y such that -1 and y is in between 0 and 1 minus x square. Okay, so is equal to, so we have the options 1 by 5, second is 2 by 3, third is 5 by 8, fourth one is, let's see, 8 by 15. Okay, so again we are going to use Green's theorem only. So applying Green's theorem, applying Green's theorem along the closed curve C, along the closed curve C, we get, so this is quite easy because you have already given the limit of x and y. X is minus 1 to 1, y is from 0 to 1, 1 minus x square. Okay, so this will be xy minus y square dx plus x square minus xy dy is equals to double integral over the region. So minus 1 to 1, because it's already given 0 to 1 minus x square, and this will be 2x minus y minus, this will be with respect to y, x plus 2y, okay, dy dx. So this is nothing but x plus y. So minus 1 to 1, 0 to 1 minus x square. This will be x plus y dy dx. This will be 8 by 15. Okay. Let me see, because options are there. So minus 1 to 1. First we will, so this is x e to y plus y square by 2. This will be 0 to 1 minus x square dx. So minus 1 to 1, this will be x into 1 minus x square plus 1 minus x square whole square by 2. This is dx. Okay, so this is nothing but x minus x cube plus, so 2x minus 2x cube plus 1 plus x to the power 4 minus 2x square, so 1 by 2. This will be dx. So this is now x to the power 4 minus 2x cube minus 2x square plus 2x plus 1. This is dx, 1 by 2, integral minus 1 to 1. So this you will get 1 by 2. This is 1 by 5, x to the power 5, limit from minus 1 to 1, minus 2 by 4, x to the power 4, limit minus 1 to 1, minus 2 by 3, x cube, limit minus 1 to 1, plus 2 by 2, x square, limit minus 1 to 1, plus x, limit minus 1 to 1. So this is 1 by 2. So 1 by 5, this you will get 1 minus minus 1. So this will be 2 by 5, okay, minus, so this you will get 0 minus 2 by 3, so 1. This is again 4 by 3. This is 4 by 3. This is again a square, so plus 0 plus, so this is 2. Okay, so 1 by 2, so this is nothing but 15. So 6 minus 20 plus 30. So this will be nothing but 36 minus 20. So this will be 16. So this will be 1 by 2 into 16 upon 15. So this will be 8 by 15. Okay. So this is your correct answer, 8 by 15. Okay. So now we'll move towards the next concept. Let's see. Okay, so the next thing is surface area. So area. So basically, surface area is basically a generalization of a concept which is known as the length of the curve. So basically, it is a generalization of the length of the curve. Okay. So first, we need to see what do you mean by surface normal. Okay. So what you do? Consider a surface. Let us say f of x comma y comma z is equals to c. Okay, or we can write it as f of x comma y comma z is equals to 0. Just take c here, and then again it is a function of f of x y z. So let us this surface. Okay, so this is your surface. Fine. So now the normal vector of the surface is, so the normal vector to this surface is basically gradient of f. Okay, and so the unit normal vector will be, and cap let us denote it by, so it is easy to see that it will be, you just take the modulus of this one, norm of this one, so this will be unit normal vector. Okay, so the other things we need to see, write down the question. Okay, so I will route down some formulas. Okay, formulas for surface area. First thing is, so suppose if the surface is given by z is equals to f of x comma y, then in this case surface area is In this case, the surface area A is equals to integral under root 1 plus zx square plus zy square dx dy. Okay, this is over R. So let us see one problem on this one, surface area. Question is, the surface the the surface area of the portion of the cone x square plus y square equals to 2z square lying above the xy plane and inside this cylinder x square plus y square equals to 9 is equal to solution is. So now you can see that the the so surface S is given is so the surface S is nothing but, so Z is equals to G of x comma y, which is under root x square plus y square by 2. Okay, so now just put it in this formula. Okay, so Zx is basically 1 by root 2 x square plus y square into 2 into 2x. So this will be x by 2, so x by root 2, this one. Okay, so 4. So here, what will be this one? So 2 into under root 2 into x square plus y square. Okay, so 2 into this will be 4, so 2 square, so z 2z. This is fine. So this is x by this you can write it as x square plus, so this is 2 into x square plus y square is 2 into z square. Okay, so this is basically s by 2z. Okay, this is your zx. Zy is again the similar way, y by 2z. Okay, so the area is double integral over r root over 1 plus zx square plus zy square dx dy, which is now this thing we need to calculate. Okay, thing will be minus 3 minus under root 9 minus x square and root over 9 minus x square under root 3 by 2 dy dx. Okay, so zx square plus basically this one, if you calculate 1 plus zx square plus zy square, this is 1 plus x square by 4z square plus y square by 4z square, and this is going to be uh, 4z square plus x square plus y square upon 4z square. So this is nothing but, so 2z square is equals to x square plus what? 2x square plus 2y square. So this will be 2x square plus y square. Wait a minute, let me write it down precisely. So, so under root 1 plus zx square plus zy square, this is basically 1 plus zx is x by 2z, so this will be x square by 4z square plus y square by 4z square. Okay, and this is now 4z square plus x square plus y square by 4z square. Okay, now this x square plus y square is nothing but 2z square. So this is 6z square, 6z square by 4z square root over. So this is nothing but root over 3 by 2. Okay, so from here we are getting, and this, so this area is, I have already written, minus root 3 to 3, and so this one is clear. So x square plus y square is 9, so the limit of y will be minus 9 minus x under root 9 minus x square, and plus under root 9 minus x square. Okay, yes, under root 9 minus x square and 9 minus x square root over 3 by 2 dy dx. Now this you can solve, so this will be minus root 3 to 3, and under root 3 by 2, this will be outside, and this will be 2 into under root 9 minus x square dx. This will be root over 3 minus root 3 to 3, and this is root over 9 minus x square dx. Okay, so under 3, so 1 by 2 root over 9 minus x square into minus 2x, x from minus 3 to 3 root over. Okay, so now, so 2 to 2 cancel out. Hello, hello, am I audible? Hello, अरे क्या कर दिया यार, अरे यार, Okay, now you can see.
Yes, sir.
So this will be root over 3 and minus root over 3 x by under root 9 minus x square from minus root over 3 to root over 3, and this is nothing but root over 3 upon root over 9 minus 3 minus root over 3 upon 9 minus root 9 minus 3. So this is minus root over 3. This is same. So this will be 2 root over 3 upon root over 6. Okay. So this is nothing but 6 by root over 6. This is root over 6. I hope this is clear.
Sir,
Oh, wait. I think I have done something mistake here.
limits.
Yeah, limit. Wait. Okay, so the thing is, area is minus root over 3 to 3, root over 3, and this one is minus 9 minus x square, root over 9 minus x square, and this is root over 3 by 2 dy dx. Okay, so this is nothing but root over 3 to root over 3. So this will be out, and this will be 2 into root over 9 minus x square dx. Okay, so this is root over 6, isn't it? Just let me know if some mistake is there. Root over 9 minus x square dx. Okay, so this is the standard integral. Now you have to integrate this one. I will just write it down the answer. So this is of the form root over a square minus x square dx. Okay, let us move towards the next question. Next question is the surface area of the portion of the cone z square equals to x square plus y square, that is inside the cylinder z square equals to 2y is equal to, okay, so this we need to find. Okay, so this cone, the surface area of the portion of the cone which lies inside this cylinder z square equals to y. Okay, so basically what we need to do, uh, we need to divide this thing into two parts, upper surface area and lower surface area, and they will and then we will add it. Okay, so surface area of the upper portion is basically equals to S, so 1 plus zx square plus zy square dx dy, and this will be equals to, so this will be equals to, so zx will be, so basically z is root over x square plus y square, so zx will be x by root over x square plus y square, and zy will be y upon root over x square plus y square. So this integral is now 1 plus x square by x square plus y square plus y square by x square plus y square dx dy, where we need to identify this s, where s is given by the intersection of the cone and the cylinder, that is x square plus y square equals to 2y. Okay, and this will give you what? So x square plus y minus 1 square is equals to 1, which is a circle. Okay, which is a circle with radius 1. 1 and center 0 comma 1. Hence the surface area of the upper portion is root over 2 dx dy. Okay, now this is now first we need to calculate this one as, okay, so this integral over s under root 1 plus x square upon x square plus y square plus y square upon x square plus y square dx dy. So this we need to change in r and theta. So this is x square plus y square, and again plus x square, so this will be 2 upon x square plus y square as dx dy, which is, oh, sorry, this will be under root 2, and this will also be under root, this will be cancel out, so this will be root over 2 this dx dy. So this is nothing but the area of this circle, okay, which is pi r square. Okay, so this is pi, and what is your radius? Upper portion is this one only, so here it is. Okay, and this is root over 2 pi. So total area, total surface area is equals to 2 root over 2 pi. I hope this is clear. Is it okay? Okay, nice. Okay. So just let me see the next problem. And question number 7. Okay, now we will move towards the Gauss divergence theorem and Stokes theorem. Theorem. Just wait a minute. Okay. So let D be a closed and bounded region whose boundary is a piecewise smooth surface. Is a piecewise smooth surface S that is oriented outwards. Okay. Let V of x comma y comma z is basically v1 I cap plus v2 j cap plus v3 k cap be a vector field field for which v1 comma v2 v3 are continuous and have continuous first order partial derivatives. Continuous first order partial derivatives in some domain containing D. Then integral over S V dot n cap sorry, this will be n cap d is equals to this triple integral over this is d delta dot v dv. This is the volume element, or this is divergence of v dv. Okay, where this obviously this n cap is unit outward normal vector, is the outward normal vector to S. Okay, Okay. Now we'll see the problem. Okay. So the question is, let S be the boundary of the region bounded by the paraboloid z is equals to x square plus y square and z is equals to 2y. Then the value of this double integral x I cap plus y square z j cap minus y z square k cap dot n cap ds is equal to, so this we need to solve. Okay, so now here your v is clear. So here your v, if you can see, x I cap, so this is your v1 plus y square z j cap, this is your v2 minus yz square, this is v3 k cap. Okay, n cap ds. So we have to apply this, just the formula. Okay, so double integral over s f dot n cap ds is nothing but this volume integral divergence of f dv. Okay, which is, so what is the divergence of f? 2yz minus 2yz, this will be cancelled out, this will be only 1. Okay, so this will be dx dy dz. So this will be, divergence of f will be 1, so this will be dz dx dy. This is the volume element. So we need to find the limit now. So z is from, okay, so x square plus y square to 2y, y square to 2y, x is again from, x is from, so s be the boundary of, so for s so z is equals to, we have to put 2y here. Okay, so y will be from, sorry, x will be from minus 2y minus y square to root over 2y minus y square, and then again y is from 0 to 2 dz dx dy. After calculating you will get 5. This limit is clear to everyone, because here this thing you just put z is equals to 2y, so you will get the limit of x in terms of y. Is it clear to everyone? You have to just apply the Gauss divergence, nothing else. I hope this is clear. Hmm? Okay. Okay. So next question is, let us see the next problem. Again based on the Gauss divergence theorem. So let S be the closed surface, let S be the closed surface consisting of the cone x square plus y square plus z square and the plane z is equals to 3. A vector field, f cap is equals to 3y I cap minus 2x j cap plus z square k cap defined over as S, then the value of double integral S f cap dot n cap ds is equal to is equal to this we need to find it out. So again here we need to use the Gauss divergence. So now f cap is what? Vector field is 3y I cap. This is your again v1 minus 2x j cap. This is v2 plus z square k cap. This is v3. So again divergence of f is, so again this will be 0, this will be 0, this will be 2z. So can anyone tell me what will be the divergence of this one?
2z.
Yeah. So this is 2z. Okay. Now using Gauss divergence, we have that this integral f dot n cap ds is basically equals to v divergence of f dv, okay, which is 2z, sorry, 2z dx dy dz. Now we have to put the limits, okay. So what would be the new limit of x? So you just need to see what is the surface. So as with the closed surface consisting of the cone this and the plane z is equals to 3. Okay. Okay. So the limit of x is from minus z square. So minus z square minus y square to z square minus y square. Okay. And limit of y will be from, so now we have to put the x is equals to 0 and y. So this will be from minus z to z, and again this limit will be this 2z dx dz. So this will be integral 0 to 3 minus z to z. Okay, so this is now 2 by 2 z square. So this will be z square minus y square minus z square plus y square dy dz. This is again 0 to 3 minus z to z, and this is 0, z square by 2, this 2 will cancel, z square, so that is minus y square minus z square plus y square. So this will be 2 by 2 z square minus z square minus y square upon root over z square minus y square. So this will be z square minus y square minus, so this will be uh, z square plus y square. This is coming 0. So I think this is 0. This integral is coming 0. Is it correct? Oh wait, sorry.
No, sir.
Yeah, sorry. I forgot the limit of which is, so this is basically the limit of x. Okay, fine. So this is 0 to 3 minus z to z, and this will be, so let us take 2z. So this will be again, so this will be 4 root over z square minus y square. Okay, this is your dy and dz. Okay, so this is again a square minus y square formula. So once you solve this one will, you will get 81 pi by 2. Okay, so this you need to solve with respect to y. Here z has no role here. Okay, so this is again under root a square minus y square, and this you can do. Okay, so now we will see the Stokes theorem, and we will see some problems on that one. I think so, yeah. So now we will see about Stokes theorem. Stokes theorem. Okay, so let S be a piecewise smooth orientable surface bounded by piecewise smooth simple closed curve C. Let v x comma y comma z is equals to v1 I cap plus v2 j cap plus v3 k cap be a vector function which is continuous and has first order partial derivative continuous, which is continuous and has continuous first order partial derivatives in a domain containing S if C is traversed in the positive direction, then this v dot dr is basically equals to this surface integral cross v dot dA. Okay, again where n cap is the outward normal vector to S in the direction of orientation of C. Okay, let us see some problems on this one. So the value of the integral of C f dot dr, where f cap is equals to 2y I cap minus x j cap plus 3y k cap, and C is the ellipse x square plus y square equals to 9, z is equals to x plus 3, oriented in the counterclockwise direction. Oriented in the counterclockwise direction. Yes. So this we need to find it out. Again, we will use the Stokes theorem. Okay. So by Stokes theorem, we have double integral over S, this so dot n cap ds, this is nothing but the f dot dr. Okay, so here this delta cross f is nothing but, once you do delta cross f, this will be this is easy to do, so this will be 3 I cap minus 3 k cap, and this was the normal unit normal vector is z minus x minus 3 upon z minus x minus 3. Okay, and this you will get 1 by root 2, and this is nothing but minus 1, so minus I cap plus k cap. Okay, so hence this integral s minus 6 dx dy f dot dr. Okay, and this is nothing but minus 6, theta equals to 0 to 2 pi, and this is equals to r equals to 0 to 3 r dr d theta, and this I think 54 pi. I hope this one is clear. Okay, so this thing only you have to do, this one. Okay, you have to find this one. Okay, so you will convert in this one. Now this one is easy, so delta cross f we have find this one, dot n cap is this one. Okay, so basically n cap is this one, and this one, so this you will get minus 3 and minus 3 to minus 6. Okay, now the next question is, so let f is equals to minus xy square I cap plus z square j cap plus xz plus y k cap. Okay, and C is the boundary of the triangle with vertices then we need to find the value of this integral. Dr is equals to this one, correct. Okay, so again here we will use Stokes theorem. Using Stokes theorem. So this is f dot dr is equals to basically curl of, that is curl of f only dot n cap ds. Now the curl of f is 1 minus 2z I cap minus z j cap plus 2xy k cap. Okay, and one thing you observe that the surface of the triangle lies on the xy plane. So outward drawn normal vector will be k cap. Okay, let me write it. The surface of the triangle lies on the xy plane, so the outward normal to s is n cap is equals to k cap. Now we have, so this is only 2xy. So this, let us say this integral is a. So this integral is a is equals to double integral 2xy dy dx. Now we have to find the limit. So this will be vertices. Okay, triangle of the vertices. Okay, so y is from 0 to x and x is from 0 to 1. Okay, this is nothing but 0 to 1, y is from 0 to x, 2x into y square by 2 and x square dx. So this is x cube, so 1 by 4. This is 1 by 4. This is x. Just wait. Let me see if there is any question left. So is it clear to you? If you have any doubt, you can ask me. Hello?
Excuse me, sir.
Yeah, please.
Can I ask one doubt, sir?
Yes, yes.
Sir, just how to switch over the limits from Cartesian to polar, sir? Actually, is there any shortcut, sir? Shortcut for a given region.
Okay, so basically you have to see what is the region. If your region is considerably good, it is not that much complicated, then it is quite easy to convert Cartesian to polar. So basically we convert Cartesian to polar once we see that some kind of term is there, x square plus y square, so that the integral will directly will become r square. Okay, so
Yes.
that is the only trick. We have to
Okay.
observe whether the Cartesian integral will be easy to calculate or converting it to polar will be easy to calculate.
Yes.
On that basis.
Actually, it's suppose the region is a standard form, then it's okay, sir. Actually, suppose x square plus y square equal to r square, then we can take the x as r cos theta, y as r sin theta.
Yeah.
Suppose if it's a standard shape other than circle, any other than
Yeah,
square
so
like.
that's what I'm saying. Whatever the function is there in the integral part, okay,
Okay.
if that includes some term kind of x square plus y square plus 2x, something like that. So if you
Okay.
convert this in polar form, this will be easier to integrate, isn't it?
Yes, sir. That's my question, sir.
Yeah.
How to convert? Suppose that it's not a standard form, other than circle, other than sphere like that.
No, no. So this one, this dx dy. So this
Yes, sir.
once you calculate x equals to r cos theta and y equals to r sin theta, this
Okay,
dx
sir.
dy is nothing but r dr d theta. Okay.
Yes, sir. Oh, it's a general thing. Okay, okay.
Yeah, it's a general thing.
Okay, sir. It's applied. It's applicable for all the shapes, sir.
Yeah, yeah.
So
It is
r cos theta.
applicable for all the shapes. Means all the region, but
Regions.
you have to be sure that
Yeah.
suppose if you are integrating on the region with Cartesian system, Cartesian
Okay.
coordinate system, okay,
Okay.
and you are and you want to convert it into polar system, polar coordinate system.
Okay, sir.
So you have to be sure that after converting to polar coordinate system, the integral will become easier to solve. Otherwise, there is
Okay.
no point of converting,
Yes, sir.
isn't it?
Yes,
Yeah.
sir.
So that part you need to make sure that
Okay.
your work will be easier to do.
Yes, sir. Yes, sir. Thank you so much, sir.
Okay,
Thank you.
thank you. So this is the end of week 8 assignments, and I think uh, this is the end of this course. So thank you so much.
Thank you, sir. Thank
Yeah,
you, sir. You're
thank you.
most welcome, sir.
Okay, so I will close the meeting now.